I would like to thank the organization of this event for the opportunity to show what we are doing at the 5G Brazil in the Research and User Case Commission. So I would like to present a little bit about the motivations of this commission. So the research and the user case has two main goals. The first one is to study the 5G ecosystems and then understand how this ecosystem can be applied to Brazil, how it can be a solution for the Brazilians' problems and for our demands. So that's what we're trying to do in this commission. It has a lot of participants from industry, academia, and also from operators here in Brazil. And we mapped the two main problems that you might be hindering the use of 5G systems in all the scenarios here in Brazil. The first one is the integration of satellites for remote areas. So you understand that satellite backhauling might be a very good solution for using 5G in remote areas. So you use satellites to get the data to the end user via 5G. And we'd like to understand how the latency in this link can affect the performance of mission-critical IoT applications in remote areas. We saw yesterday a lot of use cases for this. For example, platooning, controlling drones in remote areas. Oh, thank you. Controlling drones in remote areas and other kind of applications that demands low latency system. So we are considering a network where satellite is used to connect the base station to the core network. So it's the main backhaul for this application. The user devices are connected to the base station using 5G. You are assuming 5G new radio in this scenario, although you believe that you needed to change it for a 5G for remote areas so you can increase the coverage and use a smaller number of networks of base stations for deploying this network in remote areas. So this diagram, it shows a little bit the architecture that we are providing and the kind of applications that we are aiming to achieve. It goes from simple IoT for monitoring the environments, for example, humidity in the soil, and also location of the cattle, but also for more time demanding applications like controlling machinery in the fields, and also for real-time applications for controlling drones also. So we are providing some simulations where this network is integrated, this satellite link is integrated to the network, and we'd like to know how the application will be affected by the latency. So basically, you are providing some low latency applications. For example, we have a drone application in this case, where we'd like to compensate the wind effect on the drone position, but the control is not done by an operator in the field, but done by AI in the network, running in the core of the network. So you have two situations here. One, the application is running in the core, and another one it's running on the edge, on the base station itself. So in this case, you can show with the simulation results that the wind compensation can be much better achieved if the AI is running on the base station itself. If you put that on the core network, then the wind compensation gets a little bit worse, and you can cause collision between the drones. So it shows that although there is a high latency data link from the base station to the network, we can still deploy low latency application in remote areas. What you need to do is employ fog computing. So that's the conclusion of this study. The second one is regarding the IoT user case. Also, remote areas is again an important user case for us, but also cities, smart cities, and also security. The importance of the agribusiness, it's quite clear. So you can see that the numbers are considerable. So you can see for each region what is the percentage of the importance of the agribusiness in Brazil. So, and then we divide that by kind of production. So you can see from soybeans up to meat production. So it's very important for the Brazilian economy, and we'd like to improve that. And here you can see how is the population density in rural areas. So you can see that a lot of people are living these places, and most of these people do not have a reliable network that they can use for the connections. So the main challenges here are how can we provide coverage for this area, and what kind of impact the high latency systems control on the automation can be affecting these systems. Right? So it's also related to the previous case. And how you can reduce the subscriber cost so he can use the IoT device and also broadband access at a feasible price. So the main conclusions of the studies are that we needed to deploy time-critical IoT in remote areas. That's very important to improving the production in agribusiness applications. We need to provide a cost-effective solution for this. We cannot use only solutions that are designed to operate in urban areas. We need to have a solution that can be deployed in remote areas at a reasonable price. And low latency application, it's possible. You can have a low latency application in remote areas. What you need to do is combine it with fog computing. So these both technologies together can provide reliable and good services in remote areas. So that's all. Thank you very much for your time.